Alright, in this third video regarding limits of indeterminate forms, we're going to look at limits that involve algebraic fractions. In general, it's a good idea to really combine the two fractions together as we see here. So the first step that I'm going to do is off to the side here, I'm going to just add together 1 over x plus 4 minus 1/4. Okay, so the fraction on the left needs to get multiplied by 4, the fraction on the right needs to get multiplied by x plus 4 in order to get a common denominator to add these together. Alright, when I combine everything together and simplify, I end up with negative x over 4 times the quantity of x plus 4. So basically everything that is here in the numerator of the original expression, I'm going to substitute with this and see if I can get a nice cancellation. There we go. So now my next step is to try to get those x's to cancel one another out, and to make this a little bit more clear, what I'm going to do is rewrite the function that we have here so that it looks like this. So again, all I'm really doing here, I'm dividing by x, which is the same thing as multiplying by the reciprocal of x, which is 1 over x. Get a nice cancellation. I'm left with this. Substituting in 0 now gives me negative 1 over 16. Alright, here's another one. I'm going to attempt to approach this one the same way. Okay, note that when we combine 1 over x minus 1/2 together, we end up with 2 minus x over 2x. Substituting that in to the limit expression, this is what we get. And rewriting as before, we have this. So it looks like we have a bit of a problem here. We have a 2 minus x and an x minus 2, and those don't match. But perhaps we can force them to match by realizing this. So off to the side here, just a little note. If we look at 2 minus x, and we rewrite that as negative x plus 2, and then factor out a negative 1, we get something very similar to what we're looking for. So I make that substitution, and voila. These will now cancel out. I end up with the limit as x approaches 2 of negative 1 over 2x, which we can now evaluate using direct substitution.